So this is the next question, 3a, that is apply the block diagram reduction technique to find the transfer function C of S by R of S for the system shown. Okay. So here what we should be doing, block diagram reduction here. This is the simple block diagram they've given here. So here in this case, try to do the block diagram reduction. Okay. First step, we should be seeing that whether we can shift any summing points or takeoff points in order to make the block diagram easier. So here we can see that this takeaway point, we can shift it behind this block. Okay. So that's why what we would be having, whenever we shift a takeaway point behind the block, the multiplication would be taking place with the corresponding blocks here. So here we should be writing it as H3G1 after the shifting, and also this summing point would be shifted. So after when the shifting takes place here, we can see that these two blocks would be in parallel after the shifting takes place, so that these two would be in series. So whenever these two blocks are in series, we can multiply them. And also we have one feedback block G3, one summing point to the right hand side of the block, so that we can say that these two are in parallel now. So whenever the two blocks are in parallel, we can say that we can add them here. Okay, so that's why I've written it as G1 G2 plus G3. Okay, then here H3G1 H2, and here this is one summing point and this is one H1 here. So here what I've done is I've shifted this summing point now to the in front of the block. Since the direction of summing point is towards this side, so here we cannot say that the summing point is behind the block. Okay, so that's why the summing point, in order to shift it in front of the block, we should be multiplying this H2 with the H3G1. so here we are getting here H2 H3G1, and I've shifted this summing point in front of the block, and here we are getting two of the summing points here along with the two feedback paths. And after we shift this summing point in front of the block, we can see that this H2 and H1 are in series, so that's why we can multiply them and write it together as H2 H1. Okay, and also now we can see that this is the block reduced here. In order to make it easier, what we can do is we can remove one of the summing points and we can write it as, from this one single summing point only we can make these two blocks, that is one is for H2 H3G1, and from the same summing point we have the final feedback path, that is H2 H1, and connect it here. Okay, and here we can see that this is one minor loop here. We can apply the feedback condition, that is G of S divided by 1 plus G of S into H of S for a unity feedback system here. So if we do that, this is the answer we are getting, that is 1 divided by 1 plus G of S into H of S. Okay, since the value of G of S into H of S, they have given it as 1, it's not mentioned, so that's why 1 divided by 1 plus G of S is 1 and H of S is H2 H3G1. Along with it, this is in series here. Okay, that is G1 G2 plus G3, and H1 H2 is the feedback path. So again these two are in series, multiply them, and this is the feedback. So this is one simple final minor loop produced here. Again try to find the transfer function C of S by R of S. Okay, that is G1 G2 plus G3 divided by 1 plus H2 H3G1 divided by 1 plus G of S into H of S. So solve this separately, multiply this and cancel the H1 plus H2 H3G1 here, and these are the two terms remaining here, so we can write it like this. Okay, so this is the final answer produced for C of S by R of S for this problem. So please note it down, very important question. Okay, so this is the next question, 3b, that is construct the signal flow graph for the block diagram shown in the figure. Find the transfer function using Mason's gain formula. Okay, so here this is the block diagram they have given here. Using this block diagram, we should be drawing the signal flow graph here. Okay, so here is the block diagram given here. So first, whenever we give the block diagram, we should be replacing the summing points and the takeoff points wherever it is available by the nodes here. So this is one summing point. There are 4 summing points, and there are 1, 2, and here these are 2 takeoff points here. So that's why all the summing points and takeoff points replace it by a single node. Okay, so that's why here these are the nodes here which are replaced here. Okay, in place of summing and takeoff point, and these two are connected here along with the directions here. Okay, all the directions you should be specifying clearly. And since we don't have any block here when it's moving towards this summing point and all, from one summing point to other summing point, so that's why the gain here is, we should be conducting the transmittant gain as 1 in all the cases, but only here A and B we should be considering the gain as A and B. Okay, the rest all the gains are 1. Okay, so like this we should be drawing the signal flow graph for this block diagram. And after that, the same thing, forward paths, loop gains. So here we have 2 forward paths. Okay, this is one direction from input to output, okay, it is moving in this direction. This is one forward path, okay, and this is one more forward path, that is A and B, okay. These are the two forward paths along with the loop gain. So here we have 7 loops here, okay. If you see the figure, it's we cannot say that we are having 7 loops, but if we look into the figure carefully, we can see that we are having 7 loops. I have even made it easier by drawing the loops for you all, okay, so that you can understand it very carefully. All the 7 loops I have drawn it, okay. This is loop L1, L2, L3, L4, L5, L6, L7, okay. L1 is A, that is the simple loop, that is, this is the loop here. From this point it is starting, it is moving like this in the same direction, okay, and it is coming back here and it is terminating at the same point, okay. That is one loop I have drawn it here. Similarly L2, okay, that is from here it is moving downwards, then again from here it is terminating to the same point, that is L2, that is B. Similarly L3, that is AB. See the structure here. From here it starts, it moves like this, goes up, okay, A, and comes cross like this, and it moves towards B, so that's why A into B, then again goes up, comes here, and again comes here. So that's why this is one more loop, L3. Similarly L4, that is again, it starts from here, goes up like this, goes down B, and crosses here like this, A, like this, and like this, it terminates again at the same point, okay. That is L4. L5 is again AB. So here this is that loop, it starts from this point, it moves like this direction, and this direction. So this is one more loop, L5. L6 and L7 are the simple loops, that is, this is one loop and this is one loop, okay. So these are A and B. So like this we are having 7 loops, and there are 0 non-touching loops, okay. Taken 2 at a time. If you don't have any non-touching loops, taken 2 at a time, all are touching, intersecting each other, okay. So we have 7 loops here. Similarly, after that we should be finding delta 1 and delta 2 for the two forward paths. We know that delta k is 1 minus loop gain which do not touch the forward path, okay. Yeah, so this delta 1, we should be considering the first forward path, that is this is the first forward path, okay. We should be checking for in the first forward path which is the non-touching loop gain, okay. So here if we see that in this first forward path, this loop here is there, right, loop V, this is non-touching to this forward path, so that's why we should writing it as 1 minus B, okay. Similarly delta 2, it is 1 minus A for second forward path, that is, this is the second forward path, okay. So here this loop is there, right, A loop, okay. This loop is non-touching, so that's why we should be writing here it as 1 minus A, okay. So now we should be applying the Mason's gain formula, okay. Mason's gain formula is C of S by R of S is equal to summation k tending to 1 to the infinity pk delta k divided by delta. So C of S by R of S is equal to P1 delta 1 plus P2 delta 2 divided by 1 minus L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7, that is summation of loop gains. So P1 delta 1 A into 1 minus B plus B into 1 minus A divided by 1 minus, substitute the values of all the loop gains, that is A plus B plus AB 3 times, then A plus B. So then again simplify it, multiply this A minus AB plus B minus AB divided by 1 minus, here we have A 2 times, so 2A, B 2 times, so 2B, so here we have minus sign, so that's why minus 2A minus 2B, and AB we have 3 times, so minus 3AB, okay. So if we simplify this, here again we have minus AB, so that is minus 2AB. So that's why our final transfer function using Mason's gain formula and signal flow graph, this is the final transfer function we get, that is A plus B minus 2AB divided by 1 minus 2A minus 2B minus 3AB, okay. So this is the simple problem here using a signal flow graph, so please note it down. So the given question is, to the signal flow graph given below, determine the transfer function C of S by R of S using Mason's gain formula. We know that we have this Mason's gain formula also, and we have discussed the terms Pk, delta K and delta, and what does those terms mean, okay. During my explanation I have told you. So yeah, so now this is a simple signal flow graph given here. So first thing in formula we need to know that what is K. The K is considered as number of forward paths, okay. So here first we need to be calculating the forward path gains here. So we need to first know how many forward paths are there in this problem. Okay. So let's start with the counting of forward paths. So first simple forward path you can see is here 1 into G1 into G2 into 1 from input to output, correct? We have one forward path, so let's name that forward path as P1. Okay, first we need to be calculating all the forward paths. Okay, yeah, P1. Okay, the first forward path I've told is 1 into G1 into G2 into 1. So that's one forward path from input to output, all the product of all the transmittances. Okay, so 1 into G1 into G2 into 1, that is also we can write it as G1 G2. So this is your first forward path, that is P1. So now second forward path here is, so we have one more forward path here, that is 1 G3 G4 and 1 into G3 into G4 into 1, since it's going in a same direction. See, you can see, right? Same direction. Yeah. So the second forward path P2 is equal to G3 into G4. Okay. So we have one more forward path here, if you observe carefully, that is 1 into G1. We need to be checking the direction. Okay, it should be going in the same direction. 1 into G1 into G6 into G4 into 1 up to output. So you can see that we have one more forward path, right? 1 G1 G6 G4 1. So our third forward path is G1 G4 G6, right? Yeah. So we have one more forward path. So here we need to be very careful by checking the forward paths. Okay. So one more forward path is 1 into G3, and here from here we can go here, right, G5, and from here we can go here G2 1. Okay, that's the fourth forward path, that is G3 into G5 into G2. So these are the number of forward paths. We have 4 forward paths in this problem. Okay, yeah. Since there are 4 forward paths, we can say that k is equal to 4. Since we know that k represents number of forward paths, we have 4 forward paths here. Okay, yeah. So now next thing is what we need to be finding out. These are loops. Let us see how many loops are there in this problem. So now first let's consider basic loops. That is, this is a single loop, you can see here. This is a loop here, right? From one node it is going and it is terminating again at the same node. So that is H1 into G2, that is the loop gain. So our first loop L1 is equal to minus H1 into G2, right? So let's see the second loop now. So here we have one more loop, right? So this is again one more loop, which starting at the it starts at this point, terminates at this point. So there are transmittances we need to multiply. So we are getting minus H2 into G3, right? So we have one more loop here, that is, we can see that this is a loop here again, right? It starts at this point, goes here and comes back again, and again this is a loop here again. So their transmittances are G5 and G6, so G5 into G6. So here if we see whether is there any other loops here. So we have one more loop here, yes, L4, that is G1 G6 H2, right? It starts, see here, see carefully, it goes here G1, passes here again G6, same direction, and H2, and comes back to the same node again, right? Yeah, G1 G6 H2, that's another loop. And here we have minus H2, it would be minus G1 G6 H2. So similarly we have one more loop here, that is, which starts from here G4 H1 G6, right? See this point here, from this point it starts, G4 this direction, H1 and G6, again it reaches the same node. Okay, so that's a loop again. So you need to be knowing you need to be having a very sharp mind by seeing the forward paths and loops, because if you miss any one of the forward path or loop, the whole problem would be wrong and you would be getting less marks. Okay, yeah, so there are totally 5 loops here, minus G4, H1, G6, right? Since we have here minus H1, so it would be minus G4, H1, G6. Okay, in total we have 5 loops and 4 forward paths. So there are we need to be checking again, cross checking again, okay, whether there are any other loops or forward paths. So let's cross check the forward paths right now. So first P1 we have told it as it is G1, G2. So yeah, G1, G2, yeah. P2 is G3, G4, that is G3, G4, correct. P3 is G1, G4, G6, G1, G1, G6, G4, correct. So P4 is G3, G5, G2. So yeah, there are only 4 power paths and there are 5 loops. Okay, one is H1, G2, H2, G3, G5, G6, G1, G6, H2 and G4, H1, G6. Okay, so there are 5 loops and 4 forward paths. So now we need to be considering 2 non-touching loops. Okay, in order to calculate delta we need to be knowing this, right? 2 non-touching loops at a time. So here as you can see that we have 2 loops here, L1 and L2. So this is the loop L1 and loop L2. We can see that there are placed at 2 different corners and those 2 loops are non-touching. Okay, for this loop we have separate 2 nodes, and for this loop we have separate 2 nodes, and these 2 loops are non-touching. Okay, so first we need to be considering 2 at a time, right? So 2 non-touching loops we have L1, L2, and again we need to be checking whether we have few more non-touching loops or not. So if you see in this problem, if we have only these 2 non-touching loops, rest all the loops are intersecting with each other. So we can say that we have only 2 non-touching loops. Okay, on 3 non-touching loops there are 0. Okay, 3 non-touching we have 0. We cannot take 3 at a time, since only we have these 2 loops which are non-touching. So 3 non-touching loops we have 0. So similar K, now we need to find delta K, right? And we have got the value of K as 4. So we need to be finding delta 1, delta 2, delta 3 as well as delta 4. Okay, the formula is 1 minus loop gains which do not touch the forward path. Okay, so here all the loops here are touching the forward paths here. Okay, so for delta 1 we need to be considering the first path, P1, that is G1, G2. So in this path all the loops are touching in this part, so we can say that there are no non-touching loop gains, so it is 0. 1 minus 0 is 1. Similarly goes for delta 2. For delta 2 we need to be considering the path P2, G3, G4. In G3, G4 again all the loops are touching. So in G3, G4 path all these loops are touching to this path. So that's why again it is 1 minus 0. So delta 3 means again P3, G1, G4, G6, G1, G6, G4. Again you can see that in this path all the loops are intersecting. So 1 minus 0 equal to 1 again, and for same goes for P4. So 1 minus 0 equal to 1. So now we have so now we need to be substituting all these in the formula. Okay, so our formula is C of S by R of S equal to Pk delta K, that is we have a K value as 4, so it will be P1 delta 1 plus P2 delta 2, P3 delta 3 plus P4 delta 4 divided by our delta is 1 minus summation of loop gains, right? Summation of loop gains, we have 5 loops, so L1 plus L2 plus L3 plus L4 plus L5, okay, plus summation of two non-touching loops taken two at a time, right? We have only one loop, right? Taken two at a time, so we will be writing L1, L2. So this is your basic formula. So using this formula, we need to be substituting all the terms and we need to be getting our final answer, okay? Yeah. So now nothing much to do, only the substitution part is remaining, okay? So the forward path P1 forward path is G1, G2 into the value of delta 1, delta 2, delta 3, delta 4 are 1. So we can ignore them. So plus forward path P2 value is G3, G4. Okay. P3 value is G1, G4, G6 plus the value of P4 is G3, G5, G2, okay, divided by 1 minus all the loop gains, that is L1, L2, L3, L4, L5 minus G2, G3 minus G2, H1 plus G5, G6, correct, right? L3 is equal to G5, G6 plus G1, G6, H2 minus G4, H1, G6 plus L1 into L2. So the value of L1 is G2, G3, value of L2 is G2, H1. If we multiply this, minus into minus is plus, so it would be, sorry, this is H2, G3, okay, not G2, G3, H2, G3. So our final answer is G2, G3, H1, H2, okay. Yeah, so now again simplify this and get the final answer. So this is your final answer. So nothing much I've done, I've just multiplied minus term to all these terms here in the bracket and again written this as the final answer. So this is your required for transfer function C of S by R of S using Mason's gain formula. So here you can see that the steps are pretty simple. We have no much steps here. Just the thing is you need to be knowing how to find the forward paths and loops, and you need to be checking the signal flow graph diagrams very well, okay. You need to be knowing how many loops are there, how many forward paths are there, how many we can take non-touching loops, 2 at a time, 3 at a time, and you need to apply all of them in the problems, okay, and simplify. So this is your final answer here for this simple problem here.